Velocity time graphs and position time graphs are related. And so we're going to look at how to create a velocity time graph from a position time graph, and also how to create a position time graph from a velocity time graph. So if we start with this position time graph here, we can see that over time, as time moves on, this object is increasing its position from the origin or the reference position there to these positive positions shown here. The slope of this line, remember slope is rise over run, is positive because for every rise, every position, there is a positive up and over. So the rise of the run is positive, and this tells me my velocity. Now all throughout this entire time, the slope remains constant. So a constant slope means a constant velocity. So it's constant. So over here on my velocity graph, where I would have, this is zero velocity, and then I'd have positive velocities upside. So the numbers on this vertical axis represent how fast and in what direction the object is moving. Remember, the unit of velocity is meters per second. So if I look at the slope of the line for my position time graph over here, I can see that it is 1 over 1. So this is a very easy calculation. So the velocity is 1 meter per second. Remember, the position is measured in meters and our time is measured in seconds. So that gives us meters divided by seconds. So then over here on the velocity graph, that would translate to a velocity that is constant. So our velocity would be always at every time 1 meter per second, because at every time the slope is the same on our position time. So our velocity is constant in a flat line here. Let's look at another case where our position starts at a positive 5 meters, and then over time, 0, 1 second, 2 seconds, the object moves to positive 4 meters, positive 3, positive 2, positive 1, and then eventually to the origin, the reference position, or 0 position. So the slope of this line also, again, represents the velocity, and it is the change in the position over change in time. So for this one, let's consider 2 points here and here to find the approximate slope. So my final position is 4, my initial position is 5, divided by my final time, well, this would be 1/2 second, so 0.5, minus the initial time of 0. This would be -1 over 1/2, and that would give us -2 meters per second. So over here on my velocity time graph, the part of the axis, the vertical axis that's above the time axis, is the positive velocities. So maybe this is +1 and +2 meters per second. Below the time axis, I will plot my negative velocities. Now remember, velocity is speed with direction. So this doesn't mean slower than stopped. This just means 2 meters per second to the left, or in the opposite direction, however you define that. So since we have a -2 meters per second here, when I graph my velocity, it'll be a constant -2 meters per second. Now let's consider another case. This is a velocity time graph, and this velocity graph shows me that every second the velocity is actually greater. The initial velocity was 0, and then at 1 second it was greater than 0. At 2 seconds, again greater. 3 seconds, greater. 5 seconds, greater. 7 seconds, greater. So all the time, this is showing me that the object is moving to the right and speeding up. Now the slope of a position time graph is the velocity. But this velocity is not the same. It's getting bigger and bigger and bigger. It starts out at 0. So like before, we can create what would represent a positive increase in our velocity because initially there's 0 velocity. So I would have a 0 slope of the tangent line. And then over time, if this graph curves like a parabola, the tangent line to the curve initially is 0. Later, it's very positive, and that matches my initial velocity here of 0 and a velocity later that's very positive. So this shows me that it's moving to the right because the positions go from 0 positions to positive positions up the side here. And so over time, we can see that the tangent to the curve is greater than it was initially and will be greater even more later, just like our velocities are increasing here along the velocity time graph. So let's look at another one. In this case, the velocity is decreasing over time. So initially this object was moving very fast, and then later at 7 seconds, the velocity would be 0. So this tells me that the object, the thing that's moving, is slowing down and still moving to the right because all of these velocities are positive. And a positive velocity indicates that the object is moving to the right. So even though this line has a negative slope and looks like it's going down, remember we're reading the velocities, not the position. So over here on the position graph, what would this look like? Well, we start out with a very high velocity. So that would be a very steep slope to begin with. And then later, we reach a 0 velocity. So later, a 0 velocity. And so to connect those shapes, I would draw like a concave down parabola. And this would show me that the object is still slowing down and moving to the right. Now again, velocities can be positive or negative. So this graph shows the negative side of the velocity graph. So let's say that we have a velocity that starts at 0, but the object is moving to the left and speeding up. So for every time the velocity is more and negative. So remember, the sign just represents the direction. So a velocity of -2 meters per second is greater than a velocity of -1 meter per second. So at 8 seconds, our object is moving at -6 meters per second. That is very fast compared to 0. So these numbers are not less than 0. The negative just represents the direction. So this object is moving in the negative direction. So to represent negative direction and speeding up, over here on my position time graph, I need to start out with a very low, almost 0 slope, and move in the negative direction. Now, a slope that's up and to the right on a position time graph would indicate a positive velocity, but a slope that is in general down and to the right on a position time graph gives me a negative slope or negative velocity. So if our object starts at a very positive position, but starts from rest as indicated by our velocity graph, then the initial slope of the tangent line should be 0. And then later, we're going very fast in the opposite direction. So later on my time axis, I'm going to have a much more negative slope. And so connecting these, I get a parabola that is concave down, showing that for every moment, my velocity, remember, is the tangent, it's the slope of the tangent line. So this shows me an initial velocity of 0. This tangent line would show me a velocity that is it is greater than 0, just in the negative direction. And then here, our velocity is even more negative. So that would indicate that we're moving even faster in the opposite direction. So if we're moving faster to the left, so this graph tells me that I am speeding up while moving to the left, which is the same information I get from the velocity graph. For every time the speed is greater and it's still to the left. So this also shows me speeding up and moving left. Let's look at another one. Let's look at another. Now this one, the object starts out initially at time is 0, moving very fast in the negative direction, or very fast to the left. And then over time, the velocity changes, the speed is reduced. Remember, the speed is the number, because speed just indicates the magnitude or the number, the amount. So over time, the speed is reduced while still moving in the negative direction as indicated by the negative signs. So on my position time graph, I would have an initial very steep slope of -6. So remember, a negative slope is going to slope down and to the right. So, and it's going to be very steep. So initially we have a very steep slope. And then at 3 seconds down up here, the object has actually stopped moving. So at 3 seconds, we would have a 0 slope, so a flat line there. And all along in the middle, the slope is becoming less steep because the number is decreasing. So we're going from a very steep slope of 6 to a shallow or 0 slope here. And so connecting those, I would get this concave up parabola. So the slope shows me that it's slowing down because the slope of the tangent line goes from being very steep to being very shallow down here. And the general shape of my curve has a down and to the right. So that's a negative slope, and the slope is the velocity, and the slope is negative all the time. And so it's moving to the left or moving in the negative direction. Over here on my velocity graph, I see the same thing, that for all the time, it has a negative velocity, but all the time, it is decreasing in its speed. So it's also slowing down and moving to the left.